Okay, let's talk about a term you've probably heard 1,000 times, but it might still feel a little fuzzy. Object-oriented programming, or OOP. It is the absolute bedrock of most modern software, and I promise in the next few minutes, we're going to make this whole thing finally click.
I mean, really think about it. How do programmers build these gigantic, complex apps we use every day without them just falling apart into a tangled mess of code? How do you keep it all organized? How do you make it grow? Well, this is the exact problem that object-oriented programming was born to solve.
Before we had OOP, programming was, well, let's just say it could be a bit of a free-for-all. Imagine just writing the same chunks of code again and again and again for things that were only slightly different. It was repetitive, an absolute nightmare to update, and finding a bug, forget about it. There just had to be a better way.
And that better way came from a really simple but powerful aha moment. What if instead of just writing a huge list of instructions, we started to model our code after things in the real world? Things that have their own properties and can do their own things. And the key to this whole idea is the concept of a blueprint.
This is where we get to the two most important words in OOP, class and object. Just think of it like this. The class is the blueprint for a house. It's the recipe for a cake. It's the cookie cutter. It's the plan. And the object? Well, that's the actual house you build, the cake you bake, the cookie you stamp out. One is the design, the other is the real thing you create from it.
So, to get just a little more formal, a class is that blueprint we've been talking about. It's the master plan where you define all the potential characteristics, we call those attributes, and all the possible actions, we call those methods, that any object made from this blueprint will have.
And here's the cool part. In Python, making one of these blueprints is incredibly simple. It all starts with just this one line, class dog. That's it. You've literally just created the blueprint for every single dog object you could ever want in your entire program.
So if the class is the blueprint, what's the object? Well, an object is what we call an instance of a class. It's the real tangible thing you make from that blueprint. So from our OneDog class, we can create a whole bunch of unique dog objects. One named Fido, another named Lucy. Each one is its own separate thing with its own specific details.
But these objects aren't just data containers, right? That would be boring. We need to give them some skills. We need to bring these blueprints to life.
So, every single object has two main parts. First, it's got attributes. This is just the data, the properties. For our dog, this would be stuff like its name or its breed. And second, it has methods. These are the actions it can do. A dog can bark, right? So bark.call is a method.
But wait, how does each dog get its own unique name and breed when we first make it? That's where this special __init method comes in. Think of it like the object's assembly instructions. It's a special function that runs automatically the second a new object is created. Its job is to grab that starting data, like Fido and Golden Retriever, and assign it to that one specific object.
Now, you've probably seen this word self everywhere and thought, what on earth is that? It looks weird, I know, but the idea is actually pretty simple. Self is just how an object talks about, well, itself. When you tell an object to do something, Python automatically passes that specific object into the method as the first argument, and we call it self. So when the code says self.name equals name, it's really just saying, for this specific object that we're dealing with right now, set its personal name to whatever value we just got. It's the magic glue that keeps every object's data separate.
Okay, now that we've got the basics of classes and objects down, we can finally unlock the 4 principles that give OOP its real magic. And don't think of these as boring textbook terms. Think of them as superpowers for your code.
First up, we have encapsulation. The best way to think about this is like a protective bubble. It's the idea of bundling an object's data, its attributes, and the methods that are allowed to work with that data, all together inside that single class.
So why is that a superpower? Because it's all about control and safety. Take a bank account object. Without encapsulation, some other part of your code could accidentally reach in and set your balance to a negative number or something crazy. But with encapsulation, the only way to change the balance is by using approved methods, like .deposit or .withdraw. This protects the data from corruption and keeps everything working as it should.
Next up is abstraction. This is the superpower of simplicity. It's like a remote control for your TV.
You press the volume button. You don't know or care about the complicated electronics making it work. You just get a simple button that does the job. That's abstraction.
This makes your code so much easier to use. Imagine an object that sends emails. All you, the programmer, want to do is call a simple method, like .sendEmail. Abstraction hides all the messy, complicated stuff, connecting to the server, authenticating, handling errors, and just gives you that one simple, clean button to push.
Our third superpower is inheritance, and this one is all about not repeating yourself. Think of it like a family tree. You can have a general parent class, like vehicle, and then create more specific child classes, like car or motorcycle, that automatically get or inherit all the common stuff from their parent.
And this is a huge game changer. Instead of writing the code for brand and start in both the car class and the motorcycle class, you just write it one time in the vehicle class. The children get all that functionality for free. You only have to add the stuff that makes them unique. It is incredibly efficient. And finally, we have polymorphism. Now that's a big word, I know, but the idea behind it is awesome. It literally means many forms, and it's the ability for totally different objects to respond to the exact same message in their own unique way. It's kind of like a shapeshifter.
For instance, let's say you have a bunch of different vehicle objects, a car, a plane, you name it. You can just tell each one of them to .start. Now the car object knows that start means turning over its engine. The plane object knows that start means spooling up its jet engines. You use one simple command, and polymorphism makes sure each object does the right thing. It makes your code so much more flexible.
So, when you put all four of these superpowers together, encapsulation, abstraction, inheritance, and polymorphism, you don't just get slightly more organized code, you get a fundamentally better way to build software. You're building a whole new reality inside your program.
And it really all comes down to these three huge real-world benefits. You get reusability, thanks to inheritance. You get maintainability, because encapsulation creates those protective bubbles that stop changes from breaking everything. And all of that together gives you scalability, the power to grow your project from something small into something massive without it collapsing into chaos.
Look, in the end, this is a complete shift in thinking. OOP takes your code from being just a fragile, step-by-step script and turns it into a robust universe of intelligent objects that know how to manage themselves and talk to each other. It's a living system. So the next time you're scrolling through an app, just think about this for a second. That user profile you're looking at, that's an object, probably made from a user class blueprint. The photo you just liked, that's another object from a photo class. Which kind of leaves us with one last question to chew on. If everything we interact with digitally is built from these objects, what are the blueprints that are shaping your digital life right now?